Everyone, welcome back. In this special request video, I'm going to solve this question. The question asks us to find the derivative of this function y, that is y is equal to 1 divided by square root of s plus 1. It is not difficult to do. Recall I said finding the derivative from the first principle is an algebra way of finding a general expression for the slope of a curve. And I said if you want to find the derivative of a function from the first principle, you are going to use this formula: dy dx equals to limit as h tends to 0 f of s plus y minus f of x divided by h. In essence, to find the derivative of a function from the first principle, you have to find the values of the term f of s plus h and f of s. So then after finding the values of those terms, you just simplify the expression under the limit and cancel out the common factors wherever possible. Then after doing that, you can just evaluate the resulting expressions. But before I go and before I solve the question, one thing I want you to note is this: when I have from your the knowledge of function, recall when I have my f of x to be x squared plus 3, for example, and I want to find f of a. To find f of a, it implies that wherever you see x in this function, then you replace it with what? You replace it with a. Then I'm going to have a squared plus 3. I hope you understand now. So now to our question, we were given our function to be y equals to 1 divided by square root of x plus 1. Your y is the same thing as f of x, since function is an equation that shows the relationship between what? Dependent variable y and independent variable x. So x is an independent variable in this case, so we can say our y is equal to f of x. I hope you understand now. So from here, I can find my f of s plus h. Recall one of the things you have to do is to find the values of the term before you substitute into this formula. I hope you understand now. So it means my f of s plus h implies substituting the value of s as what? S plus h. That is, wherever you see f of x, whenever you see x in this function, you replace it with what? You replace it with s plus h. It means this is going to give me 1 divided by square root of, then my x will change to what? S plus h plus 1. If that is cleared, then I can go back to my formula. That is dy dx equals to the limit as h tends to 0 f of s plus h minus f of x divided by h. So if that is cleared, okay, let us proceed and make this substitution. Then my dy dx will now be limit as h tends to 0. Recall my f of s plus h now is what? 1 divided by square root of s plus h plus 1 minus f of s. My f of s is given as this. So that is what? 1 divided by square root of x plus 1, then divided by h. So divided by h. So if you proceed further, I'm going to have dy dx equals to limit as h tends to 0. If I were you, I can rewrite this as 1 divided by square root of s plus h plus 1 minus 1 divided by square root of s plus 1. Then you say multiply by 1 divided by h. Isn't it? If this division, your so-called all over is the same thing as this fission, and whenever you want to change division to multiplication, it means we have to multiply by the inverse of the denominator. I hope you understand now. So then I have the y, the s is equal to limit as h tends to 0. From here we can find our LCM. You know your LCM will be what? S plus h plus 1 multiplied by square root of s plus 1. So, and you know how many of these are you going to see here? Then it remains s square root of s plus 1. Then you have root s plus 1 minus, so square root of s plus h plus 1. And don't forget, we have multiplied by 1 divided by h. So if you proceed further, then I'm going to have limit as h tends to 0, square root of x plus 1 minus square root of s plus h plus 1, then divided by, what will be the product of this? Recall from your laws of sort, whenever you have square root of a multiplied by square root of b, the same thing as what? Square root of ab. So from this rule, it means the product of these, two radical is going to give me what? Square root of s plus h plus 1 multiplied by, let me write it this way. You have square root of s plus h plus 1, s plus 1 multiplied by 1 divided by h. So if you proceed further, I'm going to have something of this nature. So you have root x plus 1 minus root s plus h plus 1, then divided by, if you expand this guy, I'm going to have x squared plus x plus hs plus h plus s plus 1. You see what I mean? They multiply by 1 divided by h. So if you proceed further, I'm going to have limits as h tends to 0. Then you have s plus 1 minus s plus h plus 1, then divided by square root of, this will give you x squared, so plus 2x plus what? So you know you have your 2x here, you have your 2x here, then this will give you plus hx plus 1. So plus hx plus h plus 1. Yeah. Then multiply by 1 divided by h. So how do you proceed? Or if you like, you can bring this guy to the front to avoid confusion. I can just say this is limit as h tends to 0. Then you put 1 divided by h here. So you know you cannot proceed there. Although we can get rid of the radical in the denominator, but even if you get rid of it, the moment you still multiply it by the numerator, so you are still going to have it back. What I'm trying to say is that, you know, whenever you have something of this nature before, and I want to, rationalize the denominator, I want to get rid of the radical, then I multiply by square root of b divided by square root of b. So if you still multiply this by the denominator, you are still going to have the same thing. I hope you understand now. So in order not to stress yourself, then you can rationalize the numerator. It is not only the denominator you can rationalize. You can rationalize the numerator as well. So, and for you to do that, remember when you want to rationalize, you multiply by the conjugate. For example, now when I have square root of a plus square root of b, its conjugate is what? So square root of a minus square root of b. It is its conjugate because when I multiply square root of a plus b by square root of a minus square root of b, I'm going to get rid of the radical. You know, this is the product of difference of 2 square. You understand now? Then this one will give me root a everything square minus root b everything square. I hope you understand now. So if you rationalize the numerator using the same approach, so then I'm going to have limit as h tends to 0, 1 divided by h, then multiply by, probably let me change my marker if that makes sense. Okay, now Then this one will give me square root of x plus 1 minus square root of s plus h plus 1 divided by square root of x squared plus 2 plus hs. Yeah, I can take it out like this, plus h plus 1. I hope I'm communicating. So plus h plus 1, then multiply by, so the conjugate of the numerator. You multiply by the conjugate of the numerator, then I'm going to have square root of s plus 1 plus square root of s plus h plus 1. What you do for numerator, you have to do it for the denominator, s plus 1 plus square root of s plus h plus 1. I hope you understand now. So then you are going to have limit as h tends to 0, 1 divided by h. You know, if you apply your difference of 2 square to this guy, so what are you going to have? Then I'm going to obtain square root of s plus 1, everything squared, minus square root of s plus h plus 1, everything squared, from this guy, from this principle. So recall, when I have my a, when I have a plus b, a minus b, then the same thing as what? A square minus b square. So that's how I obtain it. So if that is cleared, if you do the same for the denominator, then I'm going to have square root of x squared plus 2 plus h s plus h plus 1. Then, so you have the product here, s plus 1 plus square root of s plus h plus 1. I hope you understand now. So, and you know, one thing you can do, actually, if you don't want to stress yourself, let's see, this guy will cancel this guy, and this guy will cancel this guy. So what do I have left? I have limit as h tends to 0, 1 divided by h, s plus 1 minus, you have to put in brackets whenever you want to subtract what is not a monomial expression. So then you have to, enclose within brackets so that the negative will affect other terms. So you have s plus h plus 1 divided by our denominator. I think, let me just copy it here so that we don't do the same thing again and again. Yeah. Okay. It has completed. So, yeah, it has a square root. You have a square root here. Then this also has a square root plus s plus h plus 1 in square root. So if you proceed further, I'm going to have limit as h tends to 0, 1 divided by h. Then you have x plus 1 minus x minus h minus 1. Then divided by all your denominator. I think I should just copy it here again. I have something of this nature. Yeah, that's my denominator. But don't forget, we have, the radical on top of it. So sh, you have brackets here. S plus 1, square root of s plus 1 plus s plus h plus 1. I hope you understand now. And you see that this guy will cancel this. S minus x 0, 1 minus 1 is also 0. This one we also cancel. The h at the denominator. Then you have minus 1 left. Then I'm going to have limit as h tends to 0 minus 1 divided by square root of x squared plus 2 plus hx plus h plus 1 s plus 1 plus square root of s plus h plus 1. Is that taken? And don't forget, the last step will now be to evaluate the resulting expression. The limit as h tends to 0. So if you tend your h to 0 now, that is whenever we see our h now, we substitute the value of 0, then I'm going to have minus 1 divided by square root of this one will give you x squared. This is 0, that is plus 2x plus 1. I hope you understand now. So then you have root x plus 1 plus x plus 1. You see what I mean? Then I think we can proceed further. This same thing as minus 1 divided by, recall that what I have inside here, this guy, this expression, it's same thing as what? So, you know, it's a perfect square. Indeed, I can say my what? I can say this guy is equal to x plus 1 everything square, isn't it? I think I'm correct. So then multiply by, so root s plus 1 plus root s plus 1. One of this plus one of this. 1 biscuit plus 1 biscuit will give you 2 biscuit. Then I have 2 root s plus 1. I hope you understand now. Then this guy will cancel this guy. Then I have minus 1. So let me just put it here. Then this gives minus 1 divided by s plus 1 multiplied by 2 root s plus 1. To proceed further, I can just take this guy out here too. Recall, this is s plus 1, which is the same thing as s plus 1 everything raised by 1. And you know, s plus 1, square root of s plus 1 is also the same thing as s plus 1 everything raised by half. It means if you apply your laws of indices, dots, s plus 1 raised to power half, then this is going to give me what? S plus 1 everything raised by 3 over 2. You see what I mean? So then we can just say what? S plus 1 everything raised by 3 over 2. And if you apply your laws of indices, you know, when you have a everything raised by m plus n, the same thing as what? Nth root of a everything raised by m. So with that, so then I'm going to have minus 1 divided by 2 square root of s plus 1 everything raised by 3, and that's your dy dx. And you can verify by your, a quick method, the QCAR method. Recall, when I have my y equals to what? X raised power n, my dy dx is what? That is nx n minus 1. I hope you understand now. And you know, my y was given to be 1 divided by square root of s plus 1, which I can rewrite as s plus 1 everything raised by minus half, right? So then if you differentiate it using this, a method, then I'm going to have minus half s plus 1. I hope you understand now. That's minus half minus 1. So then you have minus half s plus 1 minus 3 divided by 2 minus half s plus 1. Or you know, you can take this guy to the denominator, and it's going to be what? S plus 1 everything raised by 2. Then if you rewrite it properly, then I'm going to have minus half 1 divided by s plus 1 square root of 2, square root everything raised by 3. So which is the same thing as what we actually obtained here. So you can write it very well, minus 2 s plus 1 everything raised by 3. So you can see it is not difficult to do. So that's how you can find the derivative of the first principle. Remember, what you have to do is to find the values of the term f of s plus h first. So then immediately you find that you now simplify the expression under the limit and cancel out the common factor like we've done. So then you now evaluate the resulting expression. If you enjoyed the video, please don't forget to like and subscribe. Also, you can also request for a special video like this. I'm going to make a video for you if I understand your question and I'm available. Thank you.